Okay, so good evening. Here we have the topic thermodynamics, the basic fundamental discussion we have completed like system surroundings and the type of process, reversible, irreversible process, and then after extensive properties, intensive properties. Now, work derivation part, that is intensive factor multiplied with the capacity factor will give you the work. In the thermodynamics, we deal with pressure and volume work. Pressure and volume work only. You might have came across about gravitational work, electrical work, mechanical work, that is PV work, isn't it? So here the first term will be the intensive factor, intensive. In the gravitational work, mg is the intensity factor, where height will give you the capacity factor. Imagine you take a rock which approximately 1 kg with 1 meter height, you throw it with 5 meter height, with 100-meter height. So definitely there is a intensity, right? mg is the intensity factor and the force depends upon height. That's what the capacity, right? So the gravitational work, it depends upon intensity factor and capacity factor. Electrical work, that is charge into potential gradient. This you can learn better in the physics only. In the gravitational work, mass of the object, gravitational force, acceleration due to gravity g, and height of the object from the horizontal earth. Okay, and the units are mechanical work, pressure into volume difference. Units, pressure units, all work units is nothing but energy units only. Both are identical. So joule, ergs, Newton meter, or kilograms meter square per second square. These are the units. The unit conversions you see better in the physics topic. Now in the mechanical work, to understand in our thermodynamics point of view, in the chemistry, we will have a piston with a cylinder. Here the piston movement will be frictionless piston. There is no friction between the cylinder and the piston. It is a hypothetical device. Initially there is a volume existed inside the cylinder. The gas is ideal gas. In the gas state you have studied what is ideal gas. Okay, inside 1 mole ideal gas is there and the frictionless piston fitted into the cylinder. Volume is V. Volume can be expressed area into length. Okay, now work, conventional science, keep in memory, physics, conventional science and chemistry completely different, completely opposite. In the chemistry, work done on the system, positive. Work done by the system, negative. Okay, anything, the sign convention will be different in the physics chapter and in the chemistry. Okay, so here work done by the system, initial position is this one. This is the initial position. Very infinitesimal change work done by the gas, that is by the system. It is an expansion. Work done by the system is negative. Okay, so how much work? Very dl. This dl is nothing but change in length, infinitesimal change. Infinitesimal change in the piston expansion will give you infinitesimal change in work. Okay, here how much volume has expanded? The dV volume, area into length, dl. This is the infinitesimal change in volume that depends upon infinitesimal change in length. Basically, we know the pressure, force acting on unit area. Force acting on unit area is called as pressure. If the denominator capital A is 1 unit, then P equal to F. Okay, so force acting on unit area is equal to pressure. Here we are confined to the piston and cylinder, so external pressure, that is what we write, external pressure. Then force equal to external pressure into area. Okay, then come back to the work definition, force into displacement. Here what is the displacement? within the cylinder the displacement is dl. Force can be written as external pressure into area. Okay, so for infinitesimal change in the displacement, infinitesimal change in the work, to integrate the overall process, initial volume V1, final volume will be V2. The change is the delta V. Then P external into A, this is what the expression for force. Area into dl is the dV. Here we have written dV. Then we have substituted A into dl is dV. Then P external into dV. Why? We have written the negative sign here. After doing total integration, total work done, initial position to final. This is infinitesimal change. First we will calculate for the infinitesimal change. After that we do integration for overall change. For that we do integration on both sides. We will get overall work done. So that delta V, infinitesimal change in volume, will become as total change, V2 minus V1. Careful, V2 minus V1. Here the negative sign why we have given. It is a conventional sign. Work done by the system is negative, isn't it? Work done by the system is negative. But actually, as you see this one as a negative term, but I see this one as a positive term. Why? What is the reason? Because if there is no negative over here, then this delta V, V2 minus V1, okay, V2 smaller value, V1 is larger value, then that is a negative. Negative into negative, positive, right? So work is always positive term only. Work is always the positive term. But we have given the negative because in the derivation already there is a negative term inside the figure. To that we will make it positive by taking the conventional sign. Work done by the system is negative, work done on the system is positive, right? This is the basic work done, and this is very helpful for further derivations. Work done expression it is, right? Thank you.